Okie dokie, this is section 1-1, day 2. So we're going to pick up where we left off from yesterday about the domains of functions and what do you have to worry about in terms of things that you either can or can't use. So we're going to talk a little bit more about that. So first of all, in the domain of a function, what we're talking about of all the real numbers for which the function is defined. So when we think about substituting values into a function, we have to be able to put in numbers that work. So that's kind of the first part, this first point. The second one is thinking of it as all values of x that give real number answers. So whatever numbers in the domain, these x values that you can put in, that will give you a real number answer. So when we substitute values in, the answer that we get makes sense. So we're looking for those values in the function. Anything that we have to leave out of the domain, those are called excluded values. Now, if you think about what the word exclude means, it means to leave out. So excluded values mean you're leaving things out of the domain. Those are the numbers we don't want to have to use, or we can't use because they don't make sense when we plug those in. So what we're going to do is go through examples of different functions and look at what their domains should be based on these excluded values. So let's take a look at the top one here. So it says state the domain, which means they want us to say what can we use. Now this might not be a function that you recognize. It's what we call rational. It's a ratio. So you may not recognize what the graph looks like, but the issue we have to deal with is the fact that it's a fraction. So if it's a fraction, there's a number we have to be careful of. We can't ever divide by 0, so we want to make sure that there's never a 0 on the bottom. So I'm always going to be focused in on that denominator. So we're going to worry about the fraction idea here. For a fraction, the denominator can't be equal to 0. So think about then what might make that bottom 0. Well, easiest way is just to set it equal to 0 and solve. Now I know this is an easy one, but sometimes the expressions aren't easy, so we have to make sure we know what to do. So set it equal to 0 and solve. If I plugged in a -1 into that fraction, I'm going to be dividing by 0, which is not real, it's not defined. It has to be what we call our excluded value. So what would the domain be? So the domain is always all the things you can use. Well, you can use everything then except -1. So the domain would be all real numbers, use that capital letter R, where x can't be -1. So if I'm looking at a fraction like that, I'm just listing the things I can't use. So fractions, we worry about the denominator being 0. Okay, so let's take a look at the other fraction example here. So again, I have a fraction, I have a denominator. This one isn't so easy just to look at and say, oh, I know what numbers those are. So we have to solve it. So we're going to set that denominator equal to 0, and I'm going to solve. Now it's second degree equation, so degree 2, that's quadratic. Easiest way to solve a quadratic is to factor. Now if it didn't factor, your other option would be using the quadratic formula, but most of these will factor, but you know you have a backup plan, so quadratic formula will work too. So set them equal to 0 and see what values of x make that true. So we get our factors, but that's still not our x values yet. We have to set them equal to 0 and solve. So at 5 or -2, I'm going to have issues. Those are going to be my excluded values. Okay, so what can you use then? Well, the domain of the function then would be all real numbers, but x is not equal to 5 or -2. So you're kind of going at the perspective of what can't I use? That's what I'm going to exclude. So then I know what I can use then, everything except for those two values. So fraction, we worry about denominator being 0. Okay, let's take a look at some more. We're going to start in the upper left here. Take a look at the next equation, this guy right up here. Think about what that would graph as. So x squared, that's a parabola, right? So think about what values you can put in. Square times by 3, add together, add 1. Could be anything. You can use positives, you can use negatives, all of those values will work. You can graph that and it would be a continuous function. It would keep going. We have arrows on the end. There's no fraction. I don't have to worry about dividing by 0. I can literally use everything that I want. So the domain would be all real numbers. So for every parabola, your domain would be all reals. The other way to write that is an interval notation. That's -infinity to infinity and beyond, just like Buzz Lightyear. All right, now take a look at the next one. This one has a fraction again, so I'm kind of concerned about that. There's a fraction in there, which means I'm going to have to worry about the denominator being 0. But take a look at the denominator. It's 2. Can 2 ever be 0? Well, no, it's 2. So I don't have to worry about it. There's no variable down there. So I don't have to worry about the fraction part. But here's the part I am worried about. Take a look at the numerator. There's a radical. So we have to think about what we know about radicals. When you look at a radical, the number underneath always has to be positive. So the number under the radical must be positive. So if it's not, then we're not going to have a real answer, and those numbers need to be excluded. Those values of x that make that happen, make it negative, would have to be excluded from our domain. But let's take a look at that expression, this x squared plus 9. Let's think about that for a second. So we need it to be positive to be able to take the square root of it. So to be positive as an inequality, that means it has to be greater than 0. Right? So anything that's bigger than 0 is positive. Now also, because of where it's located, can you take the square root of 0? So what times itself gives you 0? Well, that would be 0. So it could also be equal to 0. Both of those would work to make that okay. So if you think about guessing and checking, think about some numbers that would make this statement underneath, this x squared plus 9, positive. So could you put in a 1? Sure. Could you put in a 2? Could you put in a 3? All of those would be positive values. How about 0? 0 squared plus 9, that would still be fine. How about negative 1? Could you put that in there? Negative 2, negative 3. When you look at all of those values, you actually figure out that expression can't ever be negative, because if you square something, you always get a positive answer. When you add 9 to it, you get an even bigger positive answer. There's actually no excluded values for this one at all. If you try, that was kind of the guess and check approach. If you try actually solving this, and you just subtract that 9 to move it over, look what it says. A number squared is bigger than or equal to negative 9. Well, sure, every squared number is bigger than or equal to negative 9 because it'll always be positive. So the domain for this one just so happens to be all reals as well. Okay, so why did I pick that one? Well, 2 reasons. One, I didn't want you to assume just because you see a fraction that means that you're going to have an excluded value. Also, just because you see a radical doesn't mean that you're going to have excluded values there either. It depends on what the expression is underneath. All right, so let's finish off with these equations anyway with a couple other examples with fractions and radicals. So let's take a look at the next one. We have a fraction, so I'm worried about dividing by 0, and I also have a radical, so I'm worried about it being negative. So you actually have 2 things to deal with because it's in the bottom. This x plus 4 is going to have to be positive to get a real number answer, so that means greater than 0. And it can't be equal to 0 either. I can't throw that equal to underneath because look where it is. It's in the bottom of the fraction. So if it were equal to 0, I'd be dividing by 0, which I can't do. Okay, so let's take the common sense approach. If you guess and check, try to pick some numbers that work. Well, could I put in a 1 for x down there? Well, 1 plus 4, that'd be 5. That'd be fine. 2, 3, 4, those are all great. How about 0? Well, 0 plus 4, that'd be fine too. How about negative 1? That would still work. Negative 2, that would still work. Negative 3, sure. Negative 4, nope, because that would be 0. Negative 3.9, totally fine. Think about where those numbers are. All the x's that are bigger than negative 4. Take a look at the statement I wrote. X plus 4 is greater than 0. If you just solve that for x, those are exactly the numbers we're talking about. If you pick any number bigger than negative 4, you're going to be a positive value under the radical. So the domain would be all real numbers where x is greater than negative 4. So you have infinitely many. So if you see a radical and you're going to have a domain, you're going to have infinitely many numbers that you're going to be dealing with there. All right, so let's finish up with one more of those. Take a look at this last one. So again, I have an expression under a radical that has to be positive. So 9 minus x squared is going to have to be greater than 0. And once again, it's not equal to 0 because it's in the bottom. We can't divide by 0. So guess and check. Think of some numbers that will work. So let's try 0 in that x in the bottom. So 9 minus 0, that'd be okay. Try 1. 9 minus 1, that'd be okay. Try 2. 9 minus 4, still okay. Try 3. 9 minus 9, not okay because it's a 0 on the bottom. But 2.9 squared, that'd be okay. How about going the other way? Negative 1, could you use that? Well, negative 1 squared, sure, because that would be 1. Negative 2, yep. Negative 3, nope. So again, everything that's in between negative 3 and positive 3 would be okay. So let's see if we can write that. So all the x's that are in between negative 3 and positive 3 would be the domain of that function. Now, that's kind of the guessing and checking approach, which some people like just fine. But sometimes you like to have something to solve. Let's go back to that inequality. I'm going to go ahead and subtract 9. divide by -1, which the bell should be going off for you there. That means we have to flip our inequality. And then to get rid of squaring, we square root. Now, because it's an inequality, when you square root, you can't really use plus or minus. If it's x squared equals 9, that's fine. But this is an inequality, so we use absolute value because it's a range of values. The absolute value has to be less than 3. That's the solution to that equation. Well, what does that mean? If your absolute value is less than 3, well, that means you're within 3 units from 0 on the number line. Well, so that would be numbers like 0, 1, 2, 2.9. Those are all less than 3. Or -1, -2, -2.9. It's exactly the same numbers as those. So you can write it either way. So if you need to kind of guess and check, that's fine. Or you can figure it out by solving. But by one way or the other, we need to be able to figure out what's okay to use. So for excluded values, we worry about two things. We worry about fractions. Denominator can't be 0. And we worry about radicals. Have to be positive. So what values make that happen? Okay, let's take a look at the last two. We'll talk about domain and range for both of these. For the circle, let's take a look at what the x's and y's are doing here. Okay, so for the x's, let's talk domain first. I'm going to do the domain in blue here. So it starts at, it looks like the point here is -5, 0, and it ends up at +4, 0. So the only places where you have points on this graph, for x, they start at -5 and they end at +4. So for the domain then, it would be all the real numbers in between -5 and +4. And it's included because it looks like that's where those endpoints are. If you want to do an interval notation, which is actually faster, we use brackets because the endpoints are included, and they go from -5 to 4. All right, what would the range be? That's the y or the output. So starting down here, and we'll do this in green, and ending up here, looks like this is up at 5, and this is down at -0, -4. So what would your range be then? Well, it looks like the smallest range value, smallest y you have is -4, and it goes up to +5. And then what's your range variable, your output variable? Has to be y. So that means in interval notation, it would be -4 to 5. So for a circle, your domain and range can't be all reals. You don't have points everywhere in your graph. But for other graphs, we do. Those have to be intervals, though. There's infinitely many points between the -5 and the 4, and the -4 and the 5. You couldn't list them. There's way too many points there. You have to do it as an interval. All right, but how about a line? Let's do domain. What do the arrows on the end of that line mean? Well, it goes on forever. So that means the domain for a line would be all real numbers. And again, you can do interval notation or capital letter R. How about the range? So our range, arrows again, continues infinitely in both directions. So for a slant line, the domain and range are always all real numbers. Now, that's not the case if you talk vertical and horizontal. Then you're limiting either the domain or the range. But for a slanted line, the domain and range are always all real numbers. Okay, so we spent some time today talking about domain of function. What's okay to use? What can you substitute in? Really important that you figure out what's excluded. What do you have to leave out? So two things to worry about. Are you dividing by something? Then you can't divide by 0. And square roots, being able to have a positive number under the radical, then you're going to have an old interval of numbers that will either work or not work, depending on how you want to look at it. All right, so that wraps up section 1.1.